The first time you are troopers, so I call you new, fresh, young talents, kind of, even though you both of you have quite some history in information security. But last year, those of you who were troopers might remember the guys from Argentina coming over and showing Evil Grade, the tool to modify patching processes of applications. And that tool was released at Troopers 08, and this will be a talk where the guys are going to show some quite new stuff with a new tool, so the same groundbreaking news I expect. When do sounds well, have fun.
We'll speak about web application firewalls. We'll introduce to you what are web application firewalls and some problems they have today. Oh, who am I? My name is Wendell. I am from Brazil. I work at Trustwave in a division called the Spider Labs. I am a network penetration test. I have over 7 years experience in the security industry. I found some vulnerabilities in webmails, access points, Citrix Metaframe, and the others. I spoke at Shot the Sheriff, DEFCON, Hackers to Hackers conference, and now Troopers. That's really great.
Okay. I'm Sandro Gauci. I think enable security and do voice over IP research / web application research as well, when it comes to security, of course. Developing an add-on to Canvas, which is a penetration testing framework. Lots of security research when it comes to vulnerabilities which affect Gmail, for example. There was the ServJack tool that demonstrated some vulnerabilities in Gmail, and development of the voice over IP security tool suite, Subvicious.
Introduction. What are web application firewalls? Web application firewalls, I believe most of you had heard about. It's a kind of technology to intend to protect vulnerabilities at web applications. Well, they are considered the next generation protection for web applications. We have even some kind of the Germany companies that create the application firewall. One example is a company called the Hyperware, the name, and we have some very famous that you take a look that are more worldwide. Well, during this presentation, we will show for you basically how we can identify systems, detect what web application is running, and some bypass techniques. Well, also we will show how some of these vulnerabilities that they intended to protect, they can also be vulnerabilities the same.
So what is a web application firewall? It's basically like an antivirus for a web application. It's a security system that you ideally put in front of your web application, and in a perfect world, your web application would become magically secure. Sometimes they are called deep packet inspection firewall, and they work using 2 techniques basically. Attack signatures, which is very similar to the antivirus. You have a list of attacks signatures to look out for. If they match, you're gonna block. And you also have the abnormal behavior detection. So you know what's normal and you block the rest. Okay, web application firewalls can be installed as software, And they can also be installed as an appliance, as hardware on your network. So you put your appliance on the network and have all HTTP requests be forwarded to your web application. Of course, only the allowed HTTP requests are forwarded to your web application. So the bad stuff or is blocked or somehow prevented from reaching your web application.
Well, basically, they have 3 different network designs where they can be applied. It can work as a reverse proxy. So you have a reverse proxy that will get all the connections and it will forward to the web server, check it, for example, for anomaly or signatures, and if it's okay, forward, get back, and send it back to the client. It can work embedded, or it's a kind of plugin that you put on the web server, or you can put it connectedly in a kind of a switch, for example, in a port mirror, so they can see all the traffic and interact with it. This last case is not so common. It's really common for some big enterprises that fear about, for example, the delay that web application firewalls can add to your network. So it's a kind of inline system. It's the less used today. Also, web application firewalls, the modern web application firewalls can do all these checks inbound and outbound connections. So they can detect even attacks that is arriving, for example, requests for command execution, execution bypass, cycle injection, and the others. And it can detect outbound, like for example, web server leaking errors, leaking SQL errors, internal stuff, credit card data to be in compliance, and the other stuff. Please, if something is not clear, you can ask us anytime, okay?
Please also, some of the vendors, if you implemented a web application firewall, maybe because of PCI DSS or something like that, you might be familiar with some of the names in here, in this slide.
Check the time. Okay, well, who's the web application firewall today? Many banks have web application firewalls. We will see some cases. Companies that are very security conscious, and a lot of companies that need to be in compliance with the payment card industry data security standard. In PCI, we have a special topic that requires that you have a web application firewall or a security source code review. So this helps a lot web application firewalls take place on the market nowadays.
Okay, so we're gonna talk a bit about the models that web application firewalls make use of. You have the negative model, which is blacklist based. You have like I said before, you have a list of signatures to look out for. Sometimes they're regular expressions, and if they match, you're gonna block. Of course, this is known to be a bit weak, so a lot of web application firewalls will make use of the whitelist approach. And with the whitelist approach, you can define what sorts of input you're expecting. If it's supposed to be a numeric value, if the parameter to a URL is supposed to be a numeric value, then alpha characters, ABC is gonna get blocked or is going to trigger the rule. And then most web application firewalls, because it's really intensive to have a positive model for the whole web application, they use a mixed model. So they try to get best of both worlds, negative and positive model together, and block it that way.
Okay. Let's speak about negative model that Sandro was talking. Basically, negative model have a kind of database where it checks the bad patterns. A common example, for example, is we have if the user sends some input where it matches a bad pattern, like a common cross-site scripting, conversion of input, or common input of a cycle injection, like select username, comma, password from passwords, it can be on the database of your rules, and it will detect this kind of stuff, and it take the action that the user, the administrator selected, like block, just log it, drop connection, or whatever was chosen.
Yeah, and I'm going to expand on the positive model. So, when using the positive model, the web application firewall needs to learn what's allowed. So you usually have the learning mode, and it will detect what sort of, so the administrator during the learning mode will probably be browsing the website, of course, using valid input, and the web application firewall can learn using those values. In this case, we have news.jsp, which is an ID, and it's only supposed to be supposed to have a value between 0 and 65535. So if it's anything beyond those numbers, if it's -1, it should trigger the rule. If it's an alpha character, ABC, instead of 1, the news article will, the web application firewall will block that request from reaching the web application.
Okay, so we'll give a brief. We'll start to speak about some common problems that this kind of technology have today. We'll speak about bad rules. We'll speak about bad design of the solutions, bad implementation, and some vulnerabilities that they have, and in theory they intend to protect to web applications. Okay, first down.
So yeah, web application firewalls, they're marketed as being silent, but sometimes they're really not. Sometimes they even put insert cookies on the browser, so you can easily find out that a web application firewall if you know that it usually sets that particular cookie. We're gonna have a small demo.
This is starting a small application to be able to see the requests that the browser is doing to a website on the internet.
Let's see if this works.
Yes, this works.
Okay. Go to this particular website.
It's the Tokyo Internet Banking.
So it's accessing the website, and we're using HTTP Fox, which is an add-on to Firefox, which shows you the headers and so on, what's happening in the background, which is really useful for us in this case. Stop this. And you can see this particular cookie, ST8ID, which is known to be inserted by a particular web application firewall, the Teros web
That's
application
from
firewall.
Citrix.
Yeah. So that's one passive way of detecting that a web application firewall is installed in front of a web application.
Here.
That's
Which
what
is- Well, another common way to detect web application files that in theory they think to be stealth, a lot of them claim to be stealth, but they are not. A lot of them, different cases, he write some headers. The most common header that they rewrite is the server header. Sometimes trying to cloak the attacker. There are different implementations. In some implementations, they change the server header all the time. In some implementation, they just change the header if they detect an attack. So this kind of behavior allows us to detect and even distinct what web application firewall they are. Here we'll see another real example testing against ArmLogic. Here, you just see it at the server value, all value indicates the name of the product, RawFancy. It's not in special only in the website of the company who created it. If you download or if you have it in your company, you can test it live on the internet. You see it's not possible to manage, to disable the name of this cloaking. In some products, for example, you can change the names and some of them do not allow. So it's a good way to detect some web application firewalls too in a passive way.
Yeah. Apart from that, you have the more active ways of detecting web application firewalls. Some web application firewalls, when they detect that there is an attack or a possible attack, they will reply with a 404 or a different error code, where otherwise they would reply with a 200, which is a valid HTML page. So you would be accessing a known to exist, a PHP script, for example, which is known to exist on the web server, and passing certain parameters to that PHP. If you pass the parameters that are allowed, you get a 200 response. And if you don't, if you insert some malicious script, something which triggers a rule, you might get a 404 or 501, or depending on the web application firewall, how it's configured and how it usually replies. And I'm going to show this in practice as well. This is another vendor who's also using his own product on his website. And this got blocked because we're trying to access cmd.exe, which is known to trigger this signature on this particular web application firewall. And you can see that, oh yeah, I'm gonna turn on the magnify. That they reply with a very funky response code, no hacking, 999. So that's an easy way to detect this particular. It's really easy.
Well, also there are some web application firewalls that act in general similar to some intrusion prevention systems. Some of them have the options to close connections in different ways. Some can send for you RST packets, or some can just drop all the connection you get. This kind of behavior allows us to detect this kind of system, and you will see in future slides that with the older techniques, we can use this kind of block to exactly identify what system they are, even if they completely block our connection.
So, apart from detecting the presence of a web application firewall, we can also fingerprint them. So we can also find out which rules, because each web application firewall has a different set of rules. They might share some of them, but each have their own set of rules. We can actually fingerprint and find out which vendor is installed. Precisely. Find out which exact. One might even find out which version of a web application firewall is installed, depending on which rules get triggered. If I know that in the April edition, product A added this new rule, then I know that this particular client of mine might or might not be running the April edition of this update.
Okay, so it should be seen. Man, it's so boring. A lot of check codes, check responses, all manual stuff. We need to know each of these products. So why not create a tool for this kind of stuff?
Okay, so we're introducing WebWolf, which is a web application firewall detection tool. It will tell you which web application firewall is installed in front of your web application, and it also has generic detections. So if it's not able to detect which particular web application firewall is installed, it might also find out. It might still find out that there is a web application firewall, because it gets information that is not expected, changes in the headers, for example, and so on. Since it's written in Python, it can run on a large number of systems, and we'll be adding more to this tool as our research develops.
Special more generic techniques to detection of application firewalls. Well, that's a common output of a web application firewall, WebWolf, sorry, and you take a look how it works in practice. You want to do the demo? Basically, here we have WebWolf, and you can test it in some of the sites. For example, we previously was aware that this site, for example, that's a Brazilian site, have a web application firewall. So you now test against it, for example, to check if you can detect the web application firewall. It's able to
increase the font size a bit. Thank you.
Yeah, but
maybe we use the magnification again.
Yeah, that might help.
be a good idea.
That might be, thank you.
Okay. For example, test it against Tenflip. With two checks, we can see it's running behind a mod security. Oops, sorry, here. We made just two requests to identify it's protected by a mod security. And so we can speak, okay, but you speak about mod security and all these mod security, positive model, negative model. Are you able to identify even positive model? The answer is yes. We can do a try in the mod security website. it's not working.
You didn't see this, okay?
Let's put in the other machine. The other headings, it's better. We'll just change the machines because it's a Windows with active Python. Okay, can I put it here? Your internet is not working. It's not working right now. Oh, too bad.
But what I can do is I can show my demo.
But you do not have the positive folders. Okay. Can you try to figure out the internet wireless? Just internet via wireless. Okay. Let's be Well, here it's not working very well, but we do not have a Unix machine in this. Yes, it's having some kind of problems, but you can try other websites. Do you remember any other?
So,
Yeah.
so same thing, but on
Yes. Polite. Yes.
okay, so same thing that we did before. It's doing it in an automated fashion. Okay, so you don't really have to know that ST8ID is the cookie belongs to that particular vendor. It will just give you a name, and that's what you want in the end of the day. Same thing with and well, it pretty much works unless it crashes. We switch to the next.
Yeah. Because it's not connected. I don't know why.
So apart from detecting which web application firewall is installed, you might want to find out what are the good strings to send to a web application, and so that the web application firewall doesn't block them. And what are the bad strings? So you can actually it can be done via an intelligent brute force way, where you try different strings and see which gets blocked, encode those different strings in different encoding techniques, and see if they get blocked. And then modify your attack. If you're doing an SQL injection attack, you're gonna avoid certain keywords, or you're going to encode your keywords in a certain manner. And that's how a penetration tester will go about bypassing a web application firewall.
Well, basically, there are different ways to bypass web application firewalls depending on the product. One of them is using variations of Unicode. Some products can be bypassed, other not. Also, we can use evasion at database layer. Another common attack is homographic attacks, where, for example, if the web server supports other language support, for example, in Portuguese, where we have accents in some common language, you can use these accents, for example, to bypass the match the web application firewall execute, but at the web application firewall, it will be matched. For example, in Portuguese, we have a kind of A, E's, and the very other different characters that have the accent, but when using, for example, iconv, the web server application, they are translated for the same. So when it arrives at the end in the web server, it will be translated as the same and executed, but the web application file, the match will be different. So that's another example of bypass using homographic attacks if your target supports multi-language.
Yeah, and it also depends on what you're doing. So if you're doing a cross-site scripting attack as an attacker, of course, HTML and JavaScript can be very flexible. If the web application firewall is looking for script tags, you might use some other way to insert JavaScript, and you might also even bypass. Yeah, we
But
have
we'll
a
talk it now.
demo for this, right?
Yeah, we'll talk. Yeah, you just prepare it.
You might even bypass by adding some characters where the HTML is still valid, but the web application firewall, the rules in the blacklist approach, the web application firewall, they don't match anymore, so the request is allowed and the attacker can still execute his or her attack. So this is Profence, which is configured to forward all requests, all requests that are okay to a web application.
Yes.
Is this working?
Yes, the cable wasn't plugged.
And we're going to show how the negative model could be easily bypassed in Profence. Oh yeah. So this would be the IP of the web application firewall, which is receiving all requests, and it's redirecting them if they pass all the rules to the other server, to the web application itself.
Do you want to take that? Speak. Okay.
So Wendell is going to try to make use of a cross-site scripting attack and hopefully get blocked. Yeah. So Armor Logic Profence kicked in and it gave a 404 error, which for a valid page actually, but it's blocking the attack, the cross-site scripting attempt. But
The same happened. Sure. It's
you
the
removed the
yeah.
yeah.
The same
Okay.
happened, do not work. But
Yeah.
if you add
But if you add some extra trailing characters at the end of script like bypass, which is very appropriate, it will allow you to bypass this simple rule. Yeah, so it actually worked. And yeah, because this works because the rule in Profence, in Armor Logic's Profence, is looking for script /script and the HTML tag without taking into account that you can put anything there after the script tag, and the browser will still execute the JavaScript code, render the HTML. So that's one really easy bypass. But you are you gonna do this?
Okay, what you can be saying again about the positive model. Okay, but positive model is much more secure. No, yes, it's much more secure. How secure it is? It's possible to bypass positive model. Again, at the Profence interface, there is a way you can create specific positive model enforcement.
So he's Wendell is going to add a new rule which only allows certain characters to be passed to that particular PHP script. So he's gonna configure and yeah, you don't have to do this manually necessarily, because this particular and other products, they have the learning mode. So you will be browsing and allowing everything, because it has, during the learning mode, it assumes that all traffic is okay unless it matches a blacklist, one of the rules in the blacklist. So if you're doing, if you have a large website, high traffic, getting attacked all the time, if you're using the learning mode on the internet itself, you might actually end up with a web application firewall that has learned bad rules. So one has to be really cautious and know about this issue. Okay?
If you request, for example, 123 ABC, it's allowed because it's inside the hood that you created. It just accepts alphanumeric contents. If you input any different contents, like for example exclamation, it denies our request. So basically we can't use it, brackets, nothing different from A to Z, 0 to 9, that's all. So it's neither percent, so it's very complex to inject it in this kind of situation.
So this is actually a bypass, but we'll just execute some JavaScript to prove that it's allowing.
Again, why does work it? Someone guess? Someone have a guess why this worked in positive model that should be really strong and enforcing it never work in a real world?